Hello everyone, my name is Dr. Arnav Samanto. Today my topic of discussion is short range forces. So what is short range forces? Short range forces in chemistry are primarily intermolecular forces that operate over very small distances, typically less than a few nanometers. So we all know that how small is 1 nanometer is. 1 nanometer is 10 to the power minus 9 meter. So short range forces acts over a very small distances. These forces are crucial for the structure and behavior of molecules, particularly in condensed phases like liquids and solids. The common intermolecular forces or interactions are hydrogen bonding, ion dipole interaction, dipole-dipole interaction, dipole-induced dipole interaction, instantaneous dipole, induced dipole interaction, or London dispersion force. The last three types of forces, that is dipole-dipole interaction, dipole-induced dipole interaction, and instantaneous dipole-induced dipole interactions, are collectively known as van der Waals forces and are generally very weak. Next is hydrogen bonding. Hydrogen bonding is a weak electrostatic force of attraction between hydrogen and typically electronegative elements such as fluorine, oxygen, and nitrogen. Hydrogen bonding mainly two types. One is intermolecular hydrogen bonding, another is intramolecular hydrogen bonding. Intermolecular hydrogen bond occurs between two different molecules. Example, water, ammonia, hydrogen fluoride. So here intermolecular hydrogen bond occurs between hydrogen of one water molecule and nitrogen of another ammonia molecule. Intramolecular hydrogen bonds occurs within the same molecule. Example, orthonitrophenol, salicylic acid, salicylaldehyde. In orthonitrophenol, intramolecular hydrogen bond occurs between hydrogen of alcoholic group with the oxygen of nitro group. Similarly, in case of salicylaldehyde, intramolecular hydrogen bond occurs between hydrogen of alcoholic group and oxygen of aldehyde group. Next is ion dipole interactions. Ion dipole interactions are attractive forces between an ion and a polar molecule. So what is ions? Ions are the charged particles. Positively charged particles are known as cations and negatively charged particles are known as anion. And what is polar molecule? The polar molecules have a permanent dipole moment due to uneven electron distribution or charge distribution, creating a slightly positive and a slightly negative end. The oppositely charged ends of the ion and the polar molecules are attracted to each other, forming an ion dipole interaction. Anion means negatively charged particles will attracted by the positively charged end of a polar molecule. Similarly, cation, that is positively charged particle, will attract negative end of the polar molecule. These interactions are crucial in solutions, especially when ionic compounds dissolve in polar solvent. The strength of these interactions increases with the charge of the ion and the magnitude of the dipole moment of the molecule. So when an ionic compound like sodium chloride dissolves in water, the water molecules surround and interact with the Na plus and Cl minus ion, weakening the ionic bonds and allowing the salt to dissolve. Ion dipole interaction also play a crucial role in biological systems such as proteins, where they can occur between ions and polar amino acid residue. Next is dipole-dipole interaction. Dipole-dipole interaction occurs between polar molecules which have permanent dipoles due to the differences in electronegativity. The positive end of one dipole attracts the negative end of another dipole. So in case of HCl molecule or water molecule, dipole-dipole interaction occurs. Dipole-dipole interaction influence physical properties like boiling point and melting points. Generally, molecules with stronger dipole-dipole interaction have higher boiling and melting points because more energy is needed to overcome these attractions. For example, haloalkanes have higher boiling point compared to the parent alkanes. Next is dipole-induced dipole interaction. Dipole-induced dipole interaction, also known as DY forces, occur when a polar molecule induces a temporary dipole in a non-polar molecule. This happens because the electric field of the polar molecule distorts the electron cloud of the non-polar molecule, creating oppositely charged regions and thus a temporary dipole. These interactions are weaker than dipole-dipole interaction. So the example of dipole-induced dipole interactions are between the interaction of polar hydrogen chloride molecule and induced dipole argon atom, and similar case occurs in case of polar water molecule with the induced dipole oxygen molecule. Instantaneous dipole induced dipole interaction. It is also known as London dispersion force. These are temporary attractive forces that arise from temporary fluctuation of electron distribution within molecules, creating temporary dipole that induce dipoles in neighboring molecules. So this is the instantaneous uneven distribution of electrons in helium atom, and this is the neighboring non-polar He atom. This instantaneous dipole induces the non-polar He atom which is situated neighboring the instantaneous dipole. So these interactions are known as London dispersion forces. So what is instantaneous dipole? An uneven distribution of electrons around the nucleus of an atom is known as instantaneous dipole. These forces occurs between all molecules but are particularly significant in nonpolar molecules where other types of intermolecular forces are absent. It is the weakest intermolecular force of interactions. These forces act over a very short distance and it acts between the surfaces of the molecule. The strength of the different intermolecular forces generally increases in the following order. So among all types of interactions, London dispersion forces are the weakest intermolecular forces of attraction, and ion dipole interactions are the strongest intermolecular forces of attraction. So these are the some important questions regarding hydrogen bonding. First question is why carboxylic acid exists in dimer form. In pure carboxylic acid, the hydrogen bonding can occur between two molecules of carboxylic acid to produce a dimer. This immediately doubles the size of the molecule, so increases the van der Waals dispersion forces between one of these dimers and its neighbors and resulting in a higher boiling point. So these are the pictorial representation of the dimer of carboxylic acid, and we can see that there are two intermolecular hydrogen bonds formed between two different carboxylic molecules. Question number 2. KHF2 exists but KHCl2 does not. Why? Hydrogen bonding is possible in molecules where nitrogen, oxygen and fluorine is present. In KHF2 molecule, hydrogen bonding is present between electropositive hydrogen atom and more electronegative fluorine atom. As a result, HF2 minus is formed. Hence, KHF2 exists, but KHCl2 molecule does not exist because there is no possible of formation of hydrogen bonding between hydrogen and fluorine atom. Next question is why does ice floats in water? When liquid water is condensed to ice, then four hydrogen bonding are formed and ice has a tetrahedral cage-like structure with a huge voided space. Thus, water expands when freezes. That is, volume of ice becomes higher than water and density decreases. Thus, ice floats in water. So in the picture we can see that one H2 molecule is tetrahedrally surrounded by 4 water molecule via forming hydrogen bonding. And the question number 4 is para-nitrophenol has higher boiling point than orthonitrophenol. Explain. Para-nitrophenol has intermolecular hydrogen bonding, so it has more boiling point and less volatile than orthonitrophenol, which has intermolecular hydrogen bonding. In orthonitrophenol, intramolecular hydrogen bonding formed between the hydrogen of alcoholic group with the oxygen of nitro group. But in case of para-nitrophenol, intermolecular hydrogen bonding for intermolecular hydrogen bond forms between the hydrogen of alcoholic group of one para-nitrophenol molecule with the oxygen of nitro group of another para-nitrophenol molecule. So these are the pictorial representation of intramolecular hydrogen bonding and intermolecular hydrogen bonding. So thank you all.